Okay, so there we go. Yeah, so what's the rule with multiplying? So 2 negatives multiplied equal positive, right? 1 negative just comes out negative, doesn't it? So in this case, then, we have a negative times a positive, so the answer is going to be negative something, and then just let your calculator do the work from there. Somebody have it? What's 7.4 times 1.2? What is it? Oh, it's just a bunch of 8s, huh? 8.88. There we go. So I'm just making sure you know the rules for the signs, right? 2 negatives multiply to be positive. One negative is just negative. All right. Okay, so how do you, so first off, we're multiplying 3/5 times negative 3. Is the answer going to be positive or negative? Yeah, because it's 1 positive, 1 negative. So we know the answer is negative something or other. And then what we did one of these right at the end of last time, huh? What's the rule for multiplying two fractions? You can go straight if you want. That's okay, but what would be a little quicker and easier? Is to cross-cancel, right? Did you catch how we talked about that? You can just cross-cancel those two, right? And then the answer is not that. Is negative 8/5, right? And we're done. Right, we good with that? Just cancel out those 3's. It's negative 8/5. That'd be good. Right, that's easier to just cross-cancel when you multiply. So when you're multiplying fractions, we cross-cancel. So that... All right, bunch of, this is going to be ugly. You guys want to get your notes ready? We better take this one down. So first up, hey, is the answer going to be negative or positive? Let's just determine that and forget about the sign. We've got nothing to worry about. Negative in the end, right? Negative in the end. We've got, what, 1, 2, 3 negative signs. So in the end, the answer is going to be negative. Negative something, right? So then I'm just going to write down the fractions and not even worry about signs because I've already taken care of that. So let's just write them all down without any signs at all. Okay, so now what's the rule for fractions? Well, it's cross-cancel, huh? When we're multiplying all those, you could just multiply all the top, all the bottom, but that would be a pain. It'd be way easier, because then you'd have a lot of simplifying to do at the end if you did that. So it's going to be way easier to cross-cancel as you go. So let's try that. So there's all kinds of ways you can go. I'm going to do this problem a couple of different ways. For example, if you have your calculator, do you guys know 18 goes right into 36 two times? Now, if you don't notice that, then you could divide them both by 2 and 4, and you could go slower.
Cross-cancel across the board.
Yeah, anywhere you want. Yeah, you can. Yeah, let me say it clearly. You can cancel anything you want, top to bottom. Anywhere. You can go top to bottom straight up and down. You can go top to bottom diagonal, top to bottom far diagonal. As long as it's something from the top anywhere with something from the bottom anywhere, you can do it. You just can't do top to top or bottom to bottom. Those guys multiply, don't they? They don't cancel. So, did I confuse you by that statement? So top anywhere cancels with bottom anywhere, even straight up and down. So I could do 18 into 36, leaves 2. Can I cancel those two 15s? Can I go like that? No, they don't cancel, right? Those 15s do not cancel, so they stay as they are. So, okay. So what else can I cancel? Is there anything else? There's really not. Nothing on the top canceled. So then, when you're all done, you just multiply the leftovers. And this 18's gone. He's not there anymore. This 36 is gone, right? They're not left over. So what's left over? 13, 1, and 1. That's just 13. When I'm multiplying now, right? The leftovers multiply straight across the top and straight across the bottom. So on the bottom, I definitely need a calculator. 2 times 8 times 15 times 15. That's a really big number. What is it? 3,600? Thank you. Is that a Casio natural display? This thing is beautiful. Let me hold it up. These things are golden. Again, I advertise. I feel like the company should give me a kickback or something. But they are. They're just a nice product. Casio natural display, right? You just tuck them in and it zips it out straight. You know, it reduces, it does everything. You're like, oh, good. Anyway, you don't have to get it. I mean, I'm just saying if you don't have a calculator, look at my one. Casio natural display. See, it takes fractions in. You can just,
Instead of putting it in decimal.
yeah, instead of putting it in decimal form, I could probably,
What did you, sorry, what's it?
yeah, Casio natural display. Let me see if I can, I don't know if this is going to work, but I don't even know what button it is. One of these buttons. Is it this one? No. It wants like a video. Is it this one? Oh yeah, it's all upside. It's you want to smile for the camera? Okay, no. That's right. Get this out of the way. There, hey, all right, something's working. So there's some way to focus in, of which I do not know. Anyway, good enough. You can see that. See, watch how this works. This is a Casio natural display. Right, see how it says Casio, where does it say natural display? Oh yeah, right there, natural display, it's a little tiny. I could blow it up, but I don't, it'd take me forever to figure out how to do that. So anyway, let me just do this. So what I'm saying is, you can just enter those fractions. What were those fractions?
-13 over 33.
Yeah, so you would just, and I'll skip the signs, we already know the signs there. So I'll just, there's a fraction, see that button I just hit right there? That's a fraction button. It makes fractions automatically. That button right there. Maybe I could try to blow this up.
I think it's the knob up there, right above where the camera is at.
This one?
Yeah, maybe it's that.
Oh, I think you're right. Good observation. Look at that. That's beautiful. Right.
Oh, I see.
All right, yeah.
Delete?
Yeah, see this fraction button right here?
Yeah.
So you just hit that fraction button, then you type in those fractions. What was it? 13 over 36, okay. So 13, and then I just push this down arrow. This is like a up, you can't see it very well, but it's up, down, right, left. Hit the down arrow, it goes down there. 36, then you hit the right arrow, boom, and then you go times. Then you hit the fraction button again. And then the next one. 1, go down, 8, go to the right, times, can't do this upside down very well, times 18 fifteenths, right? 18, go down, 15, go to the right, and times, right, 18 fifteenths, and 1 15th, so the last fraction button, 1 15th. And then just hit it, I'm going to hit this equals now. It's all typed in there, just boom, boom, comes right to the final answer. And it's also got an SD button right here. See this SD? That changes, you hit it, it goes to make it a decimal. Boom, it changes decimal, hit it again, go some scientific notation, and then back to fraction. It just rotates between them. Any form you need. It's very, very user-friendly. It's very nice. Now, I don't want to make it seem like, hey, it's just going to solve all the problems in the class. No. Chapter 1's a bunch of numbers, and we'll be done with that like today. And then the rest will be a lot of X's. So, it won't do the X's. So I don't want to fool you as to, it's not going to do everything and you can stop working. It won't do that. But anytime you run into numbers, it is very nice. It is very nice for all the numbers. We finished that one. So we good? Oh, I was going to show another way, wasn't I? Yeah, so I'll show you one other way to do this. But let me redo this one right here. So 1336 times 1/8 times 1815 times 1. So let me do it one more time. What if you didn't notice the 18 into 36 thing? Well, hopefully you would notice at the least that divide by 2, divide by 2. Or how about maybe the 8? Yeah, let me go back. I keep changing my mind. There's a million ways to do it, and any of them are fine. Yeah, the 18. Yeah, let me do that. Yeah, there's a million ways. Yeah, how about I just do the 18, 15? That's right. So, what goes in 18 and 15? 3, huh? Divide them both by 3. In other words, you don't have to write the divide by 3. That leaves 6 and leaves 5. And then you could go like 6 and 8. Or 6 into 36. What goes 6 and 8? What goes into both those? 2. Divide by 2. Divide by 2. And divide by 2. Leaves a 4. Leaves a 3. Not getting too messy and confusing. I'm just showing another way. There's a million ways to do this. Just keep dividing top and bottom until it won't go any further. Yeah. So I divided both these by 3, and then both these by 2. So these are all gone. The 3 is left, the 5 is left, the 4. Nothing else will go. Oh yeah, 3 will go into 36 actually. There is one other step. 3 into 36 12 times. And that's it, I think. Yeah. Now multiply that together, you're going to get the same answer. 13 over 3,600. So there's a million ways to go. Just be careful. It's easy to mess up.
Negative.
Yeah, oh, yeah, negative. I forgot about the negative. You're right. All right. Good. Let's move. So negative 1 to the 12th power. What does that equal? Yeah, that means negative 1 times negative 1, 12 times, right? That's what the power means. You guys know that, huh? Those power buttons, they mean multiply that thing together that many times, right? So negative 1 to the 12th power means negative 1 times, and you can do it on your calculator, but you know a bunch of 1s multiplied are just 1, and what's the sign going to be? Positive 1 or negative 1? Positive or regular 1, because it's an even amount of negative signs, isn't it? It's an even amount of negative signs. So it comes out positive, right? So that one's easy enough, I think. All right, let's, what am I doing? Okay, so they're saying negative 3, evaluate, first off, negative 3y squared. So negative 3y quantity squared is how we say that. I'm not going to give you a verbal test, but anyway, that's what that means. Negative 3y quantity, whole thing, squared. So let me give you a second. Try that. See if you can work that out. Get the answer, and I'll finish it up in a second. And then we'll do the second one in a minute. There's two. It's like two questions. Let's just do the first one first, and then we'll go on to the second one. So first, just try that one. Oh, they're telling us y is 2, huh? Yeah, you know what? I should plug that 2 in first. Yeah, let me go up, back up, guys. I'm not paying good attention to the question. Yeah, they're saying y is 2, so I better plug that in. So just plug that in to the y in both expressions, huh? So this one will become minus 3 times 2 squared, because the y was right there, and the y is 2. You with me? So I just plugged in 2 in the y slot. And so how do I work that out? Well, do the parentheses first, huh? What is minus 3 times 2? Negative 6 squared. Positive 36, right? It's positive because it's two negatives. You know it means negative 6 times negative 6. So it's positive 36. Everybody good with that first part? The trick will come in the second part. Is that true? No, that's not true. It won't be that tricky. But it's negative 3y squared. Again, what is y? 2. Plug in the 2 like that. So what is that? Is that one going to come out negative or positive in the end? It's going to be negative, isn't it? Because 2 squared is 4. Just 1 second. So that'll be negative 12. Question?
The parentheses around 2, does that end up changing the 2?
Changing the 2? So whenever you plug into a formula, you put parentheses around the number you're plugging in. So I'm plugging in 2 to that formula, so put parentheses around it. 2 squared 4. Make sense? Yeah.
It's always confusing with the top one versus the
Yeah, so on the top one, there are parentheses already there. Yeah, and see, yeah, the main thing you want to pay attention to is when you got a power like a 2 power, you want to ask yourself, who is that 2 power on? Meaning, is he on the negative or is he not? Is the negative under his influence or not? Well, in the first one, yeah, that negative is in the parentheses. So he's under the influence of the 2 power. It's going to make 2 negatives going to be positive, right? That's why that first one comes out positive. Whereas in the second one, is that negative under the power of the 2? No, only the y. Let me write that out more clearly. You guys see, that's a big deal. That'll come up again and again and again and again. Right? You see what I'm saying? When you write it like this, that the negative is not under, or it's not under the 2. Right? Whereas if you write it this way, the negative is under the 2. Everybody see that difference? What? So when there's parentheses, so the whole question is, who does that 2 have power over? Well, everybody. Well, only the immediate thing, unless parentheses extend his influence. That's really the rule, right? So in the first one, yeah, that 2 has power over the negative, so it makes 2 negatives positive. Whereas in the second one, the 2 only has power over the y. The powers are only on the immediate thing they're next to unless parentheses extend their influence. We good with that? So that's the key thing you want to pay attention to know the sign.
Thank you.
Yeah, other questions on that one? We good? That'll come up, so watch those powers, yeah.
So it's a general rule to say when dealing with exponents, the immediate left number is going to be with the sign?
So the next one, the power, is only on the thing right next to it. Yeah, so whatever sign that thing has will be the sign, unless parentheses extend its influence. Now. Oh, yeah, I can come by and grab me after class too. Yeah, I can help you.
No, I just need to set the calculator back to.
Here. All right. Oops. Come on. All right, so there it is again. So the key thing, I'll pull out the key words there. There's a 3-degree drop for every 1,000 feet of elevation. You guys know that as you go higher, I think we all know that. As you go higher in the mountains, it gets colder. That's why the rain here is producing the snow in the mountains. So the skiing will probably be good this year. So yeah, as you go higher up, it gets colder, right? So so for example, suppose it's every 1,000 feet is a 3-degree drop every 1,000 feet.
So sea level is 0.
Yeah, sea level is 0.
Okay.
Sea level is 0. Yeah, and they're saying sea level is, let's say sea level, which is 0, is 46 degrees, they're saying. So suppose sea level is 46 degrees. And what's the temperature? If you're going to go up in an airplane at 27,000 feet? How do you figure out the temperature? Boom, you got it, yeah. Yeah, because 27,000 is 27,000.
Whatever that is.
Yeah.
Give you your answer.
Yeah. So you say, so 27,000 feet, that means 27 thousands. I don't know how else to say that. It's 27 thousands, isn't it? 27 and times 3 degree for each 1,000. You guys with me? Was that 81? 81 degree drop. So it's going to be what? So it's going to be 46 degrees minus 81, isn't it?
Gives you a negative.
It's negative something. What is that? 35?
Negative 35.
Cold. Negative 35.
I have no clue. I never touched it before.
Does that make sense how we figured that one out? So a 3-degree drop for every 1,000 feet, so 27,000 feet, so 27 times 3 degrees is 81-degree drop from the original temperature of 46. That's why they seal the doors in airplanes and things like that, because it's very cold. What's that?
Why wouldn't you have zeros?
Yeah, it's because it was for every 1,000 feet. So 27,000 is 27 thousands. So every 1,000 feet is a 3-degree drop. So this is 27 of those 1,000 feet climbs. Okay? Everybody got that? Give me another second. The last one? Everybody got that one down?
Thank you.
All right. Whoops. Okay, so how about this one now? We're We're diving 95 miles below the sea level. So the person is at 95, well, not miles, meters, huh? Meters. Miles, that would be really far below sea level. So the diver is 95 meters below sea level. And then they rise, the diver rises at 4 meters per minute for 8 minutes. For 8 minutes. So if they rise, so they're way down deep, and then they start rising. I think they have to rise slowly for their oxygen levels or something like that. So if they're rising 4 meters every minute for 8 minutes, how far did they rise? 32, right? 4 times 8. 4 meters every minute for 8 minutes.
That's so they don't get the pains.
Yeah, get the air in their bloodstream, right? Probably painful. So they rise 32 meters, right? 4 times 8. And they were 95 below. So if they rise 32, so 95 minus 32, what was that? 63. So they're 63 below. So it'd be 63. Now I wonder if they want us to put in negative 63. I'll go back and check it out. They want negative, huh? Yeah, so I think they want you to say, because their position is negative 63. 63 below. Does that make sense on that? You good? 63 below. So I'm going to go back again. That's correct. You cannot divide by 0. So, yeah, what is 1 over 0? It's actually undefined. What we mean by that is we mean there's no answer. You do it in your calculator, it'll just tell you error. There's no answer. You can't do it. It's impossible. Now, what about if you have 0 in the top? What if, I know that's not the question, but what if they did, and they will sometimes, give a 0 in the top? What would that be?
0.
Yeah, that's just 0. That's okay. 0 in the top is okay, but underneath is undefined. So, yeah, so underneath, remember, 0 underneath is undefined. So just keep that in mind. Yeah, do you guys know what is reciprocal? Yeah, that's a fancy terminology. You're right. Yeah, it means upside down. How about that? I'm not so fancy in my talk. Yeah, it just means upside down. Just give it a flip. Yeah, that's called reciprocal. So it just means give it a flip, upside down, when they say what's the reciprocal. And when 1's on the bottom, and then we flip it, like 1 over 2z, that's a z on the bottom down there. And then when we reciprocal, the reciprocal is just going to be 2. You could say 2z over 1, but we never leave 1's on the bottom, do we? We just say 2z. We never leave 1's on the bottom. Why not? Who says? Why don't we leave 1's on what? So we leave 1's on the top? Right, we do. We leave 1's on the top, but we don't leave them on the bottom. Yeah, it's just because it's true. All the rules in math we're just following what's true. Think about, Z's are weird, letters are weird. Just think about like a normal number like, 4 or something. 4. Let's just take 4 over 1. Well, you know what a fraction means? It means divide, huh? What is 4 divided by 1? It's just 4. That's why we don't leave the 1 on the bottom, because it just equals 4. So it's just more simplified this way. But if you have 1 on the top, that's not true to say that's equal to 4. That's not right. 1/4 of a pi is not the same as 4 pi's, right? So that's why we have to leave 1's on the top, and we don't leave them on the bottom, because it just divides and goes away. Yeah, I think you know all that. You might not have thought about it before, but did you know that multiplying is upside down dividing, or dividing is upside down multiplying, whatever way you want to think about that. So negative 46 divided by negative 62. They're saying rewrite, notice what they're saying a weird thing. Rewrite the division as a multiply. As a multiply. What do they mean? How do you rewrite division as a multiply? Well, you just flip the 1 on the right. That's what they want. Does that make sense? Oh, and they want a fraction answer in the end. So I guess actually what they want is 46 over 62. But see what they say here?
Oh.
Yeah, they're being kind of weird. These are weird. Honestly, I'm not going to put this on the test. This is a weird question. This is just a quick little refresher to say, hey, do you realize that dividing, this just goes to the bottom? You know that. So just put it up above. The two negatives cancel. Every time the two negatives vanished, it's positive now. Right? And they actually don't want you to simplify, which is weird. All the other times we simplify. But they're just specifically wanting you to see that dividing goes to the bottom, and it's like that. That's all they're doing. It's kind of a weird question. So they're going the other way now, and they're going to write So they're writing a divide problem, negative 8.6 divided by negative 2.8, and they want me to write it as multiplication. How do you write that divide, that fraction, which is dividing, as a times? Well, it's upside down again. Negative 8.6 times 1 over negative 8.2. Do you realize that's the same thing, isn't it? It's just now written like times. Right? Because that negative 2.8 would go right back to the bottom, wouldn't it? So it's the same thing as having it over. I've just written it as a times. So that's all they're saying. Just take the 1 on the bottom and write it as 1 over. And then it's a times problem, which is exactly the same, just written with different notation. That's all they're doing, is making sure you see that multiplying and dividing are opposite relationships, like that. Is that good? Not good? Questions I can answer on that? So that's all they want you to do. They even say don't simplify. So again, these are weird. I'm not going to put these on the test. It's just a matter of flipping the 1 on the right and making it a times problem. Don't look any deeper than that. I mean, things could bug you, like why don't we cancel the signs? Why don't we? Because they said don't simplify. That's why I'm just leaving all that. Good. So we'll move on. Whoops. I did the wrong thing. All right, so 6m plus 25 over negative 63. They want me to write that as a multiply. See it already here? Over here they have the 6m plus 25. Times what? 1 over negative, because it's got to go to the bottom. It's got to be, this is the same thing as this, just written differently, huh? That's all we're doing, is rewriting the same problem as a times instead of as a divide. It's just kind of a silly exercise. Just making sure you know that's the same thing. Parentheses on that. All right.
Yeah, it's just some nerd that wanted to.
That's right. They're like, hey, we're being tricky. Do you realize? How do we divide two fractions? Yeah, flip the 1 on the right, huh? Yeah, so the way you do it is you change to times and you flip the 1 on the right. We call that invert and multiply, yeah. Because you see what happened? We changed dividing to times, and we took the 1 on the right, and we flipped it. Yeah, again, that's just the same idea. Dividing and multiplying are upside down of each other, aren't they? We just keep beating that drum, right? You hearing the drum beat? Multiplying, dividing, upside down, right? So it's got to be the 1 on the right, though. It's not the 1 on the left. You've got to flip the 1 on the right. So the 1 on the right flips, and we change to times. And then you just work it out. Now it's just a multiply two fractions problem. You guys know how to multiply two fractions. How do we do this? Yeah, well, we cross-cancel if we could, but there's nothing that cancels, huh? Right? 3 and 8 have nothing in common. 7 and 8 have nothing in common. So then you just go straight, don't you, on that one. So I just go 8 times 8, 64. Can't forget the negative. 7 times 3, 21. We're done. Just go straight. Good on that. So dividing, flip the fraction on the right, change to times. Invert and multiply. All right, let's see. Okay, so this was number 17. All right, so it's saying, what is the percent of increase or decrease in enrollment from 1995 to 1996? So from 95 to 96, what was the increase or what was the percentage? Well, enrollment went, in 1995, enrollment was that 18,260 number. It went 18,260. And then in 1996, yeah, they just want the next year. They don't even want me to use the 97 data. That's just for nothing, I guess. It became 26,373, right? Enrollment went up quite a bit, right? Yeah. All right. And so what was the increase in enrollment?
8,000.
Yeah, it's got it. Is that what your calculator says? Yeah, just subtract those in your calculator. 373 minus the 18,260. What was it? 8,113? Thank you. 8,113. That was the increase in enrollment, but that's not the whole answer yet, is it? Because what did they ask me for? Percent increase. Yeah, so what do we divide by? Whenever you talk about it, like if I said, hey, I'm hoping 20% of this class gets an A. So, well, percent means what? What does percent mean? It means the part divided by the whole, huh? You know that. So whenever we say a portion or a percent, we have to take the part and divide by the whole. So for a percentage, well, I should do it on a new line here. So, so we go, so for the percent, it's going to equal the 8113, that's the enrollment, over the whole. Now, what was the whole? It's actually what you start with. Yeah, whenever you talk about percentage increase or decrease, you mean from the starting one. Not higher, not lower. That's not the rule. It's from what you started with, right? Like if we added 10 people into this class, we don't have room for 10 people, but 10 people added tomorrow, and they said, what percentage you would be that new amount, or the 10 divided by the original starting. That'd be your percent. Because it's the part of this, right? And so whenever they're talking about what percentage in enrollment, they mean the part of the original. So percentage always means change over original, to use words to help. It's change over original. That's what percentage means. So what was the original? The 18,260. And then just hit the buttons on your calculator. Somebody have that? I could do it in my head, but I hate to show off. So I'll just let you guys tell me. Yeah, so you can hit that SD button. What is it? 0.444? How far do they say round to the nearest tenth? Yeah, so give me one more. Well, that's probably off the screen. 3.4443. Okay. Okay. Yeah, so I'll show you what we'll do with that. Everybody good there? So before I finish up the rounding thing, I want to make sure we're all good to there. So everybody see how I'm doing that? So again, percentage change means the change over the original. So I did the change over the original. We got this on our calculator, the decimal. Okay, now, that's not a percentage yet. How do I turn that into a percentage? Yeah, when you put the percentage symbol on there, it pulls it 2 to the right like a magnet. Pulls it 2 to the right. That's why there's 2 zeros in the percentage symbol, right? I don't know if you ever stayed up late at night thinking about that. There's 2 zeros in the percentage symbol. That's because there's 2 places, right? Probably many have thought that. Okay, so 40 now. So it's 44.43%, but again, I'm running out of room. I'm just scribbling everywhere here. Let me erase this. It's 44.43%, but I'm not quite done. I'm supposed to stop right here because that's the tenths place. You guys know how the places go? Tenths, this would be the hundreds. They don't want me to go that far, right? They say round to the tenth. So that means I need to stop the first place after the decimal. Remember how you round? You find the place you're going to stop at, you look 1 to the right of that place, and the 1 to the right is 5 or more, you go up, otherwise you leave it. So it's, in the end, 44.4%. That's the increase in enrollment. We good with all that? So percentage is change over original. And then it's calculated from there. All right, that's... Okay, so they're saying 9/11 equals something with a denominator of 11a. We're on 1.7 now. This is question number 1. So they're saying, hey, take the 9/11 and make its denominator become 11a instead of just 11. So I'll just go ahead and stick that down there. They're saying make its denominator become 11a instead of just 11. Okay, it's kind of weird. All right, I'll do it. So does that change the if I change the bottom, see how I've changed the bottom from 11 to 11a. Do I have to also change the top in the same way? You do, huh? Remember, whenever you do something to the top of a fraction, you have to do it to the bottom of a fraction as well. So it becomes 9a. And that's all they want. Now, I know you might look at that. I mean, you'd be right to look at that and go, hey, that needs to be reduced. Well, they specifically don't want me to reduce it. They want me to make it the way it is and leave it. Does that make any sense what I'm doing there? So this is the equivalent expression, 9a over 11a. So they're basically saying, hey, we changed the bottom from 11 to 11a, change the top in the same way. So I did. They're just making sure you're comfortable with doing something to the top and the bottom of a fraction, is all it is. So it says 8q equals what over q squared? So So what you want to do is you want to look and say, okay, what was done to the bottom? And I'm going to do the same thing to the top. What makes Q into Q? What was done there that makes Q into Q squared? Well, I know you might think, yeah, so I should say it's not, we can't think about square, I think about multiply. Well, I mean, you're right, they squared it, but they did it by multiplying something. What did they multiply here? And we have to multiply the same thing. What did they multiply the bottom by? To make Q into Q squared. Another Q, huh? They just put another Q in the bottom. That's what made one Q into Q squared, huh? So we have to do the same thing. So they're just wanting you to look at these problems and say, hey, what was multiplied on the bottom? Do the same thing on the top. So if Q was multiplied on the bottom, I've got to also multiply Q on the top. So this will become 8Q, and we're done. That's all they want. Does that make sense? So all we're doing is we're looking and saying what was multiplied on the bottom, multiply the same thing on the top. They're just getting you ready for when we do fractions in a little bit, and we multiply top and bottom by the same thing all the time. On that. You guys are all, there's a lot of baseball wear in here, I'm noticing. Is it like, it's not even baseball season. Giants and the Dodgers are, it reminds me, if I could tell my own, I went to a Giants-Dodgers baseball, and I haven't been to a baseball game for years. It was my 25th anniversary. My sweet little wife is a big Dodger fan. Sorry, Giant fans. And so I got tickets. You know, normally I don't have money for that kind of thing. Like I said, I got 5 kids. Anyway. So I bought tickets for a Dodger game and took her to a Dodger game last semester, and with the Giants, I wanted to see, and it was kind of getting close to the pennant race. It was exciting for me. It was exciting, and I was hoping to get a good pitching matchup. I was watching who was pitching and the pitching rotations online, and it was when who's the big Dodger pitcher? What's his name? The big star, Kershaw. Kershaw, right? He's the best pitcher in the world, basically, right? He's the top paid, number one pitcher in the universe at this current time, right? I mean, it's something to see, I think. I get excited about seeing somebody that talented. Anyway, and so I was watching, and Kershaw was out. He was sick. And again, I'm going on about my sports story here. And I'm like, oh, I know. So I booked a certain day, and I paid all that money online. It's crazy what sports costs. I'm like, anyway, and it turned out I got to see Kershaw Bumgardner. I got to see the ideal matchup. It was wonderful. And the Dodgers won. Sorry, Giant. But Bum was great. Bum just cut him down, and they pulled Bum out at the end, and then the Dodgers rallied on the relievers. Anyway, very exciting. I get to see 2 of the best pitchers in the world. All right, so anyway. All right, so they want me to simplify. So negative 44 PQ over 165 PQ. All right, so they want me to simplify that. So notice the instructions. Simplify. If you're ever, remember what you do, guys? If you're ever reading these things, you're like, I don't know, because sometimes they go one way, sometimes they go the other. It can be confusing. Like, what do they want me to do? They want me to multiply the bottom. They want me to, if you're ever unsure, remember what I said last time, or maybe I didn't say it. Click on the question help button. And do the show me an example, and just hit enter, right to the bottom, take you 10 seconds, and you'll see the final answer, and you go, oh, okay. You'll know what kind of thing they want you to do if you're ever unsure. Okay, anyway, getting back to it. So they want me just to cancel these guys, don't they? I can just cancel. Now, 44 and 1, I don't think anything goes into those. You can try your calculator, but nothing, right? Oh, 11. Oh, did you just know that off the top of your head?
No.
Oh, you could have lied to me. I would be very impressed. Calculator tells you. Okay, so I guess 11 goes, I know 11 goes to 44. I didn't know 11 went to 165. So I guess they're both divisible by 11. What's the bottom? What's 15? Oh, okay. And that's 4. So the answer then is minus 4 15ths. That was a tricky one. Top and bottom were divisible by 11. Casio Natural Display will do it automatically, and some other calculators too. All right, we good? So that's just simplify the fraction. Just reduce the fraction. You guys got that down? The P's and Q's canceled, right? And then I just reduce the numbers. Recording button, yep. It's happening. So, all right. So commutative law, 78 plus Q, commutative law. What's the commutative law? Do you guys know that one? I mean, I wouldn't expect you to know. It's kind of a weird thing, but yeah, it's the flow. Like when people commute, what do they do to work? They go back and forth, back and forth. It just is a switch. It's just fancy words for switch. Honestly, I'm not going to put that on the test. It just means switch the order. That's all it means.
Same answer.
Yeah, it's the same answer. That's the point, is that it would be the same answer. Adding, the order doesn't matter. You're exactly right. That's their point. So all they want you to do on this problem is switch the order. That's using the commutative law, the back and forth law. Again, I don't put the weird, you'll see the practice exam. You'll see, I don't put weird things like, so the associative law now on this one. So we've got P plus Q plus 79. They want me to use the associative. Do you know what that means, guys? It means you move the parentheses over the other two. So you see how the parentheses are on the back two, like they're making you do the back two first? Well, if you put the parentheses on the first two instead, the fact that you can do that, that's allowed and legal when it's all just adding, that's not always allowed. If they mix in multiplying and other things, it might not be allowed. But in this case, when it's all just adding, it is allowed. It doesn't really matter which two you do first. So all I did was jump the parentheses to the other two. I can associate the other two first instead of the back two first, and it comes out the same in the end. Right? You know that. Think about numbers. If that seems weird to you, I mean, it is kind of weird, but just think about numbers. What if I was to do this versus this? Would they be different answers? Be totally the same, huh? Because this would be what? 7, and 2 plus 7 would be 9. If you did this first, it's 5, and 5 plus 4 is the same answer in the end. That's all they're doing, is they're saying, hey, do you realize if it's all just adding, we could jump the parentheses to the other two, associate the other two, and it'd be the same. That's all they're doing. Again, I'm not putting weird stuff like. Okay, so 17 P plus 10, and they want me to multiply. So how do I multiply? What do they want me to do? They want me to take that 17 and go boom and boom to both those, right? Remember distribution? Remember whenever there's anything right in front of parentheses, it wants to multiply all the things inside the parentheses. So 17P plus, and then 17 times 10, 170. Just puts the 0 at the back, and that's it. That's all they want. They're just seeing if you remember the distribution rule. Anything in front of parentheses, it multiplies the things inside. Is that good? It's all review. They assume you really have had this stuff. Okay, so 12 in minus 4. So try that one. Go ahead and distribute that one. Multiply, which means to distribute. Take that 12, boom and a boom. 12 in minus 48, right? Use calculator if you're rusty on some of those times tables. That's all they want. Good. All right, let's look at the fractions. So 5/7 B minus 35. So they want me to distribute, same thing, right? Whatever's in front of the parentheses multiplies both the items on the inside. So 5/7 B, nothing fancy there. But then 5/7 times 35, I'm going to have to work that out further. So let me first just write it like that, and then I'm going to work this out more also. Is everybody good so far? I just took that 5/7 and just put it right next to the B and put it right next to the 35. That's what anything in front of parentheses does. It multiplies both those two. Now, how do we do this right here? Good. Whenever a fraction is interacting with a whole number, put that over 1. Make it look like a fraction, huh? Okay, and then what? Yeah, what did we learn about multiplying fractions? You can cross-cancel, huh? 7 goes into 35 5 times. And so what do we got? We got 5/7 B. That one's just sitting there. Minus. So what are the leftovers? Yeah, 5 times 5, 25. And we don't need to put the 1 on the bottom. Remember, we skip 1s on the bottom because it would just divide and be gone. So that's our answer. We good with that? So we cross-cancel and multiply the leftovers. No questions? Is that good? All right, so we have 1/6 and x minus 5y minus 3z. So give that one a try. Let me whip it out real quick. Go ahead, go through the steps there. That's a 6 in the front there, 1/6. Give you a second on that one. distribute that. One-sixth x. The 5 is over 1 and the 3 is over 1, huh? Whole numbers are over 1, aren't they? So when the 1/6 goes there, the 6 goes to the bottom, doesn't it? And then I'm going to simplify the 3/6 also. But is everybody good so far there? Is that making sense? Right? Because again, whole numbers are over 1, aren't they? Whole numbers are over 1. And so that 6 on the bottom goes underneath the 5 and underneath the 3. That good? Keeping the top stuff and the bottom stuff separate there. And so then this needs to be reduced to be what? 1/2, right? Divide top and bottom by 3 and it just becomes 1/2. And there we go. That good? On that, is that okay? So just distribute. The whole numbers go over 1 and then reduce. No questions? Okay. So okay, so 3m plus 21. They say factor. Do you guys know what factor means? What does factor mean? Yeah, GCF. Kind of said. It means the opposite of multiply. It's basically unmultiply. They're basically saying, hey, what was this thing before it became 3m20? It's kind of like work backwards. They're saying like, hey, there was like parentheses, there was some number out front, 2 numbers inside here. You know, what was it that multiplied and became 3m minus 21? That's just to kind of think it backwards, like a parenthesis kind of thing. Like, what was, there was something outside and 2 things inside, and whatever that was, it multiplied and became 3m and 21. What was it before it was multiplied? That's what factoring means, unmultiplied. Yeah, so how do you know what goes in the front here? Yeah, it's whatever number goes into those 2. So that's a 3. That's a plus. It's kind of a sloppy plus. Yeah. Now you see how we got the 3 out there? Why did I get the 3? That's called the GCF. We'll get later. We'll get really serious. We'll have a whole chapter on factoring, and we'll go really slow and real detailed over all this. But for now, this is kind of a quick, small amount. What goes into 3 and 21? 3 does. Well, 3 goes into 21 7 times, and 3 goes into itself, obviously. So 3 is the number that goes into both 3 and 21. That's the greatest common factor. You don't. We'll write all that down later and get more detailed in a chapter or 2. Anyway, so that's how I know the 3 goes in outside. And what goes on the inside? Whatever works, huh? 3 times m and 3 times 7. And that's what they want. That good? We happy? Okay, so 70p minus 20q, again, factor. So that means you're thinking about parentheses, a subtraction in the middle, 2 things on the inside, 1 thing on the outside. Let me let you go ahead and try it. So what goes on the outside is whatever number goes into 10 and 70 and 20. So figure out a number, the biggest number. You need the greatest number. 2 goes into 70 and 20, but that's not the biggest number. 10? Yes, 10, right? 10 is the biggest number, the greatest number, that goes into 70 and 20. Huh? We don't want to use 2, we don't want to use 5. They both go in, but we want the greatest amount they have in common. The greatest number that goes into both of them, and that's 10. So you always put the most you can in the front, the greatest amount they have in common. And then how do you know what goes on the inside?
70.
Whatever works, huh? 10 times what would go back to 70p? 7p, huh? And 10 times what would go back to 20q?
2q.
2q, we're done. This is what they want. So we're just reverse multiplying, aren't we? We're just saying what was it before it was multiplied, before it was distributed on that. Does that make sense? Everybody see how I came up with the 10 out there? It's called the GCF. Again, it's the greatest amount. It's called the greatest common factor. It's the greatest amount they have in common. 10 is the biggest number that goes into those two. Right? Questions on that? That good? How we doing? Just where you guys start fading out. Am I starting to do the Charlie Brown teacher voice? Wah, 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 after an hour and a half of talking? All right, so number 20. All right, so factor 10x plus 45y minus 35. They want me to factor it. All right. So try that. So it's the same thing. It's just got 3 of them instead of 2 of them. So big old parenthesis, 1 thing on the outside, 3 things on the inside with pluses and minuses between them. Give me a second to try that. So you want to figure out what number goes into 10, 45, and 35. You're not sure, just use your calculator. It's 5, isn't it? Yeah. It's 5. So that's what you want out here, right? The GCF, the greatest amount in common as a factor. And now how do you know what goes inside? Whatever works, right? 5 times what? We'll go back to 10x. 2x, yeah. And 5 times what? We'll go back to 45y. You just calculate if you're rusty. 9y. And 5 times what? We'll go back to 35. 7, we're done. This is what they want. They want that whole thing. So we just found what it was before it was distributed. That's called factoring, unmultiplying. Good there? So let's try. Okay, so we have 7/6x minus 11/6y plus 1/6. And then they're telling me, okay, they're kind of giving me some help. They're saying, all right, it's a big old parenthesis. It's going to be 1 over something. See how they're telling me that in the answer setup? 1 over something. What's it going to be? Well, what do they all have in common? 6. Right? They all have that 6, don't they? 1/6. So 1/6 times what will go back to 7/6x? 7x is correct. Are we all good with that? See how that'll work? Because that 7x is really over 1. You don't have to show the 1. But it really is. And that's why the 6 will go to the bottom and the 7x will stay on the top. And it's all good. You don't need to show the 1. It just means that, right? Minus, what's the next one? How do you get 11/6y? 11y, right? And then the last one plus, what? How do you get 1/6? You got to put a 1. You do have to put the 1, don't you? Because if you just leave it blank, that would be 0. And multiplying by 0 would not go back to 1/6. 1/6 times 1 will go back to 1/6, right? So we do need a 1 there. Sometimes students just leave a blank. But you do need a 1 there, right? That will multiply correctly to go back. We good? All right, so 9z plus z. All they want me to do is collect like terms or gather like terms. So how do you do that? What are they talking about? Yeah, just add them out. What's really in front of this z? There's a 1 in front of that second z. Where there's no number, it means 1. 1 times z is just z. I haven't changed anything. So 9z and 1z? 10z. And you don't make it z squared, do you? You just leave it. When do you do that? When do you make squares? Multiplying, right? We'll get to that soon. But if you're just adding, you just add the numbers in the front. You don't mess with the powers. It's just 10z. That's all they want you to do. Okay, so minus 63 minus 9m plus 3n minus 38, so along with plus n plus 2m. All right, so they want me to gather like terms. So let me let you go ahead and do that. So give that a try in your own papers there, and I'll finish it up in a second. Feel free to check with those around you. So you do the numbers with the numbers, the m's with the m's, and the n's with the n's, right? Gather like terms. Okay, so minus 63 and minus 38. Just use your calculator. But they're going to actually be a bigger negative, aren't they? Right? We give me that minus, was it 101? Minus 101. And it doesn't matter what order you do these in. You can do the letters first or the numbers or whatever. Minus 9m plus 2m. Minus 7m, right. And then plus 3n, and then just a regular n, that's really 1n, is 4n. And again, you could put these in any order. Scattering like terms, remember all that? And I don't exactly remember what it looked like again. Let me see. Okay, yeah, so 10z plus z plus 2/15 z. Okay. Yeah, they want me to combine all those, right? And the problem is we got a fraction. If that just wasn't a fraction, it wouldn't be any problem at all. So that's a z in the, I don't know, I'm scribbling too badly there. It's a z in the middle. All right, so we're supposed to add those up. Well, that's a 1z in the middle, so that part's easy, 11z. But how do we add the 11 and the 2/15? That's where we're at now. You guys good to there so far? So I need to add the 11 and the 2/15. And they want a fraction in. Look at the blue line. You know they want a fraction in the end. They don't want a decimal. So if you have a Casio Natural Display, you can just type it in and it'll just do it. If you don't, you got to put the 11 over 1 and you got to get what? Common denominator. To add or subtract fractions requires a common denominator, right? So I've got to multiply, remember, by the other denominator. So top and bottom by 15, right? And so that'll be, is that 165 over 15z? And the other one, we don't need to mess with the other one because it already has the 15 denominator, huh? See how I've made both denominators 15 now? You just multiply top and bottom by the other denominator. So now you can add them. So what is that? 167, 15, yeah, z. And then it's fine for the top to be bigger. You don't have to fool with it. It's good. It's like that. As long as nothing divides out, right? I don't think anything goes into 167. I could be wrong. I thought that earlier today, and I was wrong. But I don't think anything goes into 167. It's fine for the top to be bigger. Is that good on that? Remember that common denominator stuff? Fraction. So what do you do when you've got a minus sign in front of a fraction? So you got, I'm not fraction. Why am I saying fraction? Minus sign in front of parentheses is what I mean to say. Yeah, what's that? Yeah, it's a minus 1 really. Or you don't even have to make it a 1. It's just a minus sign, or it is a minus 1. You're totally right. And it's going to distribute into the parentheses just like anything in the front of parentheses does. So that minus will distribute, and you'll get minus y minus 66. And we're done. That's all they want on that one. Is that good? So just reminding us, anything in front of parentheses distributes in. Minus sign, number, letter, whatever. Anything in front of a parentheses multiplies everything inside. Okay, so here we have 43d minus parentheses 9d minus 60. Okay, so what do we do first on this problem? Normally we've been trained, and rightly so, to always go to the parentheses first and do what's in the parentheses first, right? But the problem with that is we can't on this one, can we? You can't subtract 60 from 9d. Those are unlike terms. So yeah, if we could do the parentheses, then we would do those first, but we can't. We can't do anything inside those parentheses. So we can't do that, so then what are we going to do? Distribute, yeah. That minus sign in front of the parenthesis, remember, anything up against the wall of a parenthesis is like water up against a floodgate. The wall comes down like a dam or something, right? The wall comes down and the water rushes in. That's exactly what happens with anything up against a parenthesis. Whether it's a number, a letter, a sign, whatever, anything up against the wall. I'm trying to give you those two thoughts. I'm going to let down the wall. So on the next line, there'll be no more parentheses. I'm going to drop the dam gate, I'm going to drop the wall, and the water is going to go in, right? That's exactly what happens. So that minus is going to go boom, boom. It's going to go in. The minus will hit the 9D and just be minus 9D. No more wall. No more parentheses. The wall came down. The water went in. And then the minus also hits the minus 60. Minus with minus? Plus. Again, no more wall. The walls came down. So whenever you let something from the outside of parentheses, and there's the secrets of math. Oh, no, I'm just kidding. I just had to play with you. I told all the secrets of math. And it's over.
Oh, yeah,
and it wasn't
okay.
recorded. No, I'm sorry. Play with it. All right. So yeah, so a minus sign outside parentheses, or anything outside of parentheses, is going to hit both the items on the inside, and that's when the walls come down. So you drop them off, and there it is. 43D minus 9D.
34.
So what that is? 34? 34D. Just distribute, and we're done. We can't add those, can we? Why can't I add those at the end? Unlike terms. One's got a D, one's just a number. Yeah, so we're done right there. Does that make sense? Okay, so anything up against parentheses. Okay, so 79Z minus 10 minus parenthesis 52 minus 30Z. So here we go again. I cannot do what's in the parentheses first. You can't subtract those. They're unlike terms. So instead, you take the minus that's up against the wall of the parenthesis and you distribute. So go ahead and do that first. Let me let you do that. A minus is going to go boom and boom, won't it? And on the next line, there'll be no more parentheses, right? The walls come down. The water rushes in. And then just combine line terms.
That's the trick.
There it is. The secret. Okay, so the 79Z, the minus 10 just sit there for a minute, and then it's minus 52, and the minus hits the minus 30Z to be plus, right? Two negatives multiply to be positive, don't they? We good to there? So far, so good. No more parentheses, right? Whenever something from the outside goes in, we drop them off. Now, just do the like terms. 79Z and 30Z. 109Z, and then minus 10 minus 52, minus 62. And there we go. That's as much as we can do. Is that okay? It's going to get uglier. We got 20 minutes. I hope you're still feeling sharp because it's going to get a bit uglier here. So you good with that? They're about to ramp it up. This is the hard section. Okay, so 4x plus 2y minus 7. And we have 4x, in the parentheses, 4x minus 8y plus 6z. All right, give it a go. You know that minus 7 is going to distribute through the parentheses, huh? Use your calculator if you need to. Let's get some of those multiplications. And that is, by the way, a minus 7. Don't just multiply regular 7 through there. And it's a good time to talk about signs. You know, you want to think about any sign that's in front of somebody, like that minus in front of the 7. That's his negative sign. I know we kind of think about it as being in the middle, but really it's on the 7. It's the 7's baby. You don't leave your baby behind, right? It takes that minus sign with it wherever it goes. So the minus 7. Boom, boom, boom. In we go, right? Boom, boom, boom. So well, here, let me just bring that 4x and 2y. They're just sitting there watching. The parentheses are going to drop off. The walls are coming down. The water's going in. So minus 7 times 4 is minus 28x. And then minus 7 times minus 8, two negatives, positive 56y. And then minus 7 times plus 6 is minus 42z. No more parentheses. I've got one more step. But good so far? Does that make sense? And now combine like terms. 4x minus 28x minus 24x, 2y and 56y, 58y, and then the 42z is just there's nothing to combine with. So that's it, right there. Is that good? They're going to ramp it up even a little bit more. So we good so far at that level? We're only 1/3 of the way through this section. We good there? Question? Oh, 4x minus 28x. You good? Any other questions I can answer on that one? All right. Okay, so 6 bracket 7 minus 4 parenthesis 4 minus 9 parenthesis bracket. A bracket is the same as a parenthesis. It just looks different. So in a minute they're going to bring in curly brackets because they'll want a third layer. It's the same. All those kind of things are the same. They just look different. All right, so where do we start? Yeah, start in the innermost set right here, right? 4 minus 9. And these are just numbers. There's not even any letters anywhere. So we can just combine. I don't even have to distribute. Now, hold on. This will probably confuse some people. Probably some of you guys are thinking, I mean, I would too. If I was you, I would be thinking, aren't we just going to take this and go boom and a boom? You could. That's okay. There's nothing wrong with that. But I don't have to. Since these are both just numbers, I can just take 4 minus 9 and get -5, and that would be easier. But either way would work out fine in the end. Do you guys understand what I'm saying? Like if this one had an x or something, then I would have to distribute, wouldn't I? Because I couldn't subtract 4x minus 9. They'd be on like terms. But if they're all just numbers, then you don't have to distribute. You can actually just subtract the numbers on the inside, and that would be a little easier. You seeing the difference? Why sometimes we distribute when there's letters, and they're not like terms. And sometimes if they're all just numbers, then I don't need to do any fancy distribution stuff. I can just subtract. So I'm not going to distribute, even though that's okay and the answer would be the same. I'm just going to go, look, 4 minus 9 is just -5. Good so far? Right? 4 minus 9 is -5. And then 7 minus 4 is 3. Right? Right?
Yes.
No. Right. I just made an error, which tons of people make. That's why I'm doing it. Yeah. Look at the 4's life. He's got two demands on his life. He's being asked to multiply by the -5, and he's being asked to subtract from the 7. Math is not done just simply left to right. I mean, it usually ends up being left to right. But the overriding rule is not left to right, it's what? Yeah, have you heard of the order of operations? Now, you don't really have to get all obsessed with that. It hardly ever really matters much. I'll write it out, but I wouldn't make a big deal out of it. It's not a big deal. It's the whole PEMDAS, you know. But and P means, it actually means problems. Yeah, problems inside parentheses. What does E stand for? Exponents. Means powers, you know, powers. And M and D is multiplying and dividing. A and S is adding and subtracting, I'm sure you know. But my point, though, notice two things. M and D are on the same level. M's not before D. They're same level. And A and S are same level. So how do you know which one you do first? Then you just do left to right. So adding, subtracting are the same as each other, so you just do them left to right. Multiplying, dividing are the same as each other, so you just do whichever one's on the left first. They're the same. Some people think multiplying is always before dividing. It's not. They're the same. So that's one thing. The P, the parentheses, does not mean any. This is what people think with parentheses. So a lot of people know the PEMDAS, but they don't really understand some of the details of the PEMDAS. They think, oh, P is parentheses. We always just, anywhere there's parentheses, just go there and do that. Not so. That's not what that P for P means parentheses, but it means problems inside parentheses. Just inside. Not anything involving any parentheses anywhere, no. Just if you got, which is what I did, right? I had a problem inside parentheses, so I did that first. That's what that P means, just inside parentheses. Anyway, so my point with the this being wrong is the 4 will multiply before he will subtract, because multiplying is above subtraction, right? So watch out. So really, having said the whole PEMDAS thing, you don't need to memorize the whole PEMDAS thing. If you just remember this, adding, subtracting is last. You'll be fine. That's the mistake that gets everybody. Nobody has any trouble with the parentheses and the exponents. Pretty much you naturally do that right. The thing that trips people up is they add, subtract too quick. Remember, what's last? Adding, subtracting. The simplest of all operations, right? Remember that's last and you'll be fine. So when you look at this, you go, oh, no, I'm not going to subtract. That's last. Just remember that's last. And you'll go, oh, no, I can't do that. So what do I do instead? I multiply instead, don't I? So the 7 just sits here, and I can't subtract. Instead, I go -4 times -5. Two negatives? Positive 20. Right? Is that good? And here's the other mistake. Sometimes I've seen students do this, and they'll make it a 20 like that, and all of a sudden it's 7 times 20. That's not true. That 7 was never, ever multiplying things. It'll never become multiplying. It's either going to be add or subtract, depending on the sign. You can't change it into something it never was, right? All along, that 7 was saying, I'm going to subtract something, or maybe add if the sign changes, and the fact the sign did change. So now it's going to add. All right, next you add those, 27, and now we multiply, what's that, 120, 41, 62? Thank you, that's the right answer. Is that good? You remember all that kind of stuff? Ooh, 10 minutes. We got uglier. Yeah, brackets are just another parenthesis. Exactly. And so is the curly bracket. So I'm going to write this out. 3, curly bracket, regular bracket, 4, B minus 4. This is an exercise in carefulness. Plus 18, bracket, minus, bracket, 3, parenthesis, 2b minus 3, plus 2, bracket, curly bracket. Yeah, parentheses, brackets, curly brackets, they're all just parentheses. They're just fancy parentheses. They all do the same thing. All right, guys, where are we going to start? Do we have letters in this one? Yeah, so we're gonna have to do some distributing. So I would start writing here and distribute, because I can't subtract 4 from B. They're unlike. So I have to just write. When letters get involved, then you have to distribute, don't you? So now be careful. Try. I wouldn't do the whole thing at once. I would take it a little slowly. It's a little big there. So 3. Curly bracket. So what's that going to be? That's going to be 4b minus 16 plus 18. Now notice what I dropped off, guys. I dropped off the parentheses, but not the bracket. What? Because that wall came down, right? The wall between the 4 and the b came down. That's why the 4 multiplied the b. But the bracket wall didn't come down. So when does a wall come down? When something from the outside of that wall goes in. Right? Nothing from the outside of the bracket has gone in, but something from the outside of the parenthesis went in, so he's gone. You see that? So when something from the outside goes in, that wall's gone. And over here, I'm going to let the parenthesis wall drop. It's going to be what? 6b minus 9? We good to there? Good so far? Now, let's, there's a few options here. I'll probably combine these two. They're just numbers. 4b, what's that going to be, plus 2? Right? You see what I did there? Minus 18 minus 16, basically. Right? Minus 16 plus 18. Football team loses 16 yards, gains 18. Your bank account loses $16, gains 18. You're up 2. Right? Use a calculator if you need to. Over here, minus 9 plus 2. Bank account loses $9 and gains 2. $7 down. Good so far. Now what? This guy's going boom, boom. No, he needs to, we got water outside a floodgate still. That needs to go in, right? And when it goes in, the wall's coming down. What's in front of this parenthesis right, this bracket right here? Nothing. So just dry, it's a dry floodgate. Just drop the walls. Nothing's going in. In a minute, the 3 will go through everything, but he's sitting out there waiting for a minute. So I'll drop this, drop this. There's nothing in the front of that floodgate. But when I drop this floodgate, the negative sign goes in, becoming negative 6b and plus 7. Did you see that? See how that negative hit? See how that negative hit the 6b and then hit the negative? Negative, negative, plus. Right? And those walls are down. The brackets are down. Now finally, now you could do it, you could distribute now. Why don't we combine first? How about I combine? I'm running out of room here. So I'm going to combine 3, curly bracket, 4b minus 6b, negative 2b, and then 2 and 7, 9, and finally the 3. The curly brackets are coming down. The 3 will distribute minus 6b plus 27. Just as easy as that. All right, we got to try one of those. We got 5 minutes. Questions on that one? Question? Monday, Wednesday, and we miss next Monday. Right, so this homework will be due next Wednesday. All right, so let's do this one, guys. Here's my question. That minus 8 squared, is that going to become a positive 64? It's 8 times 8, right? 8 squared, 8 times 8. Positive 64 or negative 64?
Positive. Negative.
Yeah, it's a trick. It's really, it's a kind of a trick. There's a difference between negative 8 squared and negative 8 parentheses squared. Remember what we talked about a few minutes ago about who the 2 has power on? Remember what I said? A power only has power on the immediate thing it's on, not even the sign in the front of that, unless parentheses extend its influence. So in this case, that 2 is only on the, it's not even on the minus. I know we think of it as, well, isn't that minus is? Not really. It's really a minus 1 kind of like in front. So it's minus 64. The negative doesn't get squared in that case. The 2 only has power on the 8. Whereas in this case, it is positive because the 2 power is affecting the whole thing. See that difference? So again, what's the rule? Powers are only on the immediate thing they're on unless parentheses extend their influence. Not even on the sign in front. So is this 2 on that minus? No. He's not on it. There's no parentheses there. He's only on the 8. So it stays negative, doesn't it? And the bottom is 100 plus 4. So then that's what? Minus 54. That's 104. Being kind of scribbly there. And then, can we reduce that fraction? We got, when we can divide, we must. I don't know, what goes into those? 2? 2 at least. Maybe something else. Yeah, probably just 2. 27 and 52. Anything else? Yeah, it stays negative, yeah. 13. No, that's it. Yeah. Does that make sense on that? Watch that sign trick. Powers are only on the immediate number unless parentheses, not even on the negative sign, unless parentheses extend their influence. Question?
So that power was a 3.
Right.
So inside the parentheses, so negative 8 power of 3. So that would make it negative number?
Yeah, because odd powers make it negative anyway, and it wouldn't even matter. It'd be negative either way, huh?
Yeah, so it'll be negative either way for the.
It would. It would.
As long as you decide on the even number, it'll be positive.
Yeah, even numbers make it positive. Hold. Okay, so try this one, guys. So hold on. No leaving yet. Let's get this. Will be good for you. Let's do this one. And then we'll stop. So minus 5 squared minus 8. So decide if that's going to be a negative 25 or a positive 25. And then finish it from there. Negative 33. Yeah, so does this 2 have power over this minus? No. There's no parentheses. So that minus just stays there, and it's just minus 25 minus 8, and that's minus 33. We good with all that? All right, I will stop.